Go.
Welcome to Physics 101!
Camera girl.
So you guys know how in Star Wars they say, use the Force?
Yeah.
Well, what they're talking about are forces. Forces are,
Yeah, good job. A force is a push or a pull.
it's that simple.
It's that simple. So now you guys learned a fancy word. Go home and tell your parents, hey mom, hey dad, I know a fancy word for push or pull. A force.
Now reach inside your desk and pull any object out and put it on top of your desk. Now, what I want you to do is push it in any direction. So let's imagine this is your object. I'm going to push it that way. I'm going to push it this way. I'm going to push it up. I'm going to push it down. Every time I pushed it, I was putting a force on it. I was
Okay,
pushing.
so for you viewers at home, take out something anywhere around you and just place it right in front of you. Push or pull it.
Both of these are examples of forces. Now there's this really smart guy and his name is,
Isaac Newton.
and he made these 3 rules or these 3 laws. What you guys just saw, pushing or pulling, that's his first
Now it's
law.
snack time!
Yay!
Do you guys know that even these apples have physics in them?
What?
There's these things called newtons, and that's how much one force weighs. This guy, Isaac Newton, was standing under this big apple tree when all of a sudden an apple fell on his head. Bonk. And then he said, I wonder how apples fall to the ground. So that's how he started looking up what's called gravity. Do you guys know what gravity is?
Yeah.
Have you heard about it?
Yeah, it's what keeps you on the ground no matter what.
Yep.
Good job.
Because from the center of the earth, something called gravity pulls us towards it. That's why everything in this room and all over earth is able to stay on the ground.
I come right crashing to the ground. Though this apple in the air comes right crashing to the ground.
Also, whenever something is coming straight down like this apple, it's called free fall. That apple is in free fall. Free fall is an object that's falling straight down to the ground until it can't go any
So do
lower.
you guys remember Isaac Newton?
Yeah.
And do you guys remember how we had 3 laws?
Yeah.
Well, now we're going to demonstrate the second law. Can I have any volunteers? I'm good. Okay, so this is what I want you to do. Come and sit into this wagon. And want to be really safe over here. So for the viewers at home, if you guys try this, make sure you have parent guardian.
Okay.
Okay, so keep your
now-
hands and feet in the wagon. So now we're just gonna, you guys remember what a pull is called? Force! Attaboy, good job.
So do you guys see as she's pulling, it goes faster?
Yeah.
And as she's pushing, it gets faster?
Yeah.
Well, her getting faster is called acceleration. And whenever the force or her pushing or pulling it increases or gets bigger, then the speed gets bigger too. And whenever her pulling gets weaker or smaller, then her speed gets smaller too. Talk about Newton's third law. And that's when 2 objects are pushing on each other or pushing off each other. So what we just explained to you guys, the pushing against each other or pushing off against each other is called third law pairs, and it's Newton's third law.
So now to demonstrate this, let's all get into partners. Get into a partner close to your height. For the viewers at home,
Higher than him.
find a partner close to your height and try to do this activity.
So everybody get back to back with your partner and cross your arms. Now you're gonna push each other's backs against each other. Okay? Now turn around and face your partner. And you're gonna push each other from your shoulders. 1, 2, 3, push. Did you guys feel how you guys were both pushing
Go.
each other?
Yeah.
So there's a second part to Newton's third law, and that includes free body diagrams. And that's where the Earth is pulling on us with gravity. Remember when we talked about gravity with the apple?
Yeah.
The Earth is pulling on us with gravity. That's why we're able to stand here. But also, we're pulling on the Earth. It might not feel like it. It doesn't feel like you're pulling on the Earth because it's way too heavy, right? But we are. That's why we're able to stay here. If the Earth was pulling on us harder than we're pulling on the Earth, then we would just sink straight down into the Earth. But if we were pulling the Earth way harder than the Earth is pulling us, we would fly like Superman and go straight up. But sadly, we're stuck to the ground.
Are you guys ready for today's race? Well, today's race is going to focus on this obstacle course. Are you guys ready? Yeah! Okay, so first you guys are going to have to go across each step. As soon as you go across each step, you're going to go upstairs, down the hill, across each step, across straight to this, climb it, go down, and straight to the finish line. First one that gets here is winning. Let's
Go!
Let's go, let's go, let's go! Go, kids! Go, 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 go! You guys can do it! Go, kids, go! You guys got this! Yeah, let's go! Let's go! You guys got this! Come on, guys! Oh, we got a big over there! Okay, let's go! Okay, let's go! Let's go!
A few moments later.
Whatever you want, good job. Come on, let's get it on there. Abby, you did
Race you guys just did involves something fancy called kinematics. It involves position, displacement, distance, speed, velocity, and
acceleration.
repeat after me. Position,
Position,
distance,
Distance,
displacement,
displacement,
speed,
speed,
velocity,
velocity,
and
acceleration.
First, we're going to talk about position. Position is where you're at a certain time. So at any time, maybe when you were right there, that's a position. When you were on that step, that's a position. When you're climbing up to the top, that's a position. Next, we're going to talk about distance. Distance is every step you guys took across the whole track. It all adds up to be your total distance.
Displacement, however, is just from a starting to an end. So when you guys were doing this course, you guys started at a starting line, which was at that ribbon, and you guys ended at another ribbon, which was the ending line. That's the displacement.
So straight from the start to the finish, that straight line is going to be your displacement.
You guys understand?
yeah.
Good.
Cut.
Did you guys notice that when you were racing each other, you had to go faster to beat the other person? Okay, well that means that you guys had a change in velocity because you guys had to go faster. Whenever you guys change your velocity to go faster, that's called acceleration. Say
Acceleration.
Now we're going to show you
Cut.
guys another example of speed versus acceleration. Are you ready?
Yeah.
Harmon's having a lovely jog outside at the same speed until a bee Okay, did you guys see how Harmon was running at the same speed at first? That was her constant velocity because she was running at the same speed until Mr. B came, and then
And then I had to run as fast as I could to get away from that beat, and I had to change my velocity to do that. So a change in velocity is acceleration. You guys know our favorite game, tetherball? Well, guess what? It has physics in it.
You guys see how the ball keeps on going in a circle around this pole? Well, that's called circular motion. Circular motion is when the ball keeps on going in a circle and it's always changing its direction.
Can we repeat that? Circular motion?
Circular motion.
Good job.
Now, if the ball had a constant velocity, or if it was going at the same speed in the same direction, then it would just fly away from random place. It would go straight that way or straight that way, and it wouldn't keep going in a circle.
What fun would that be?
In order to have circular motion, it needs to be constantly changing its direction and its speed around the place.
So did you guys see how I just made that shot?
Yep.
Well, I shot it with a specific angle and a specific velocity in a specific direction. Now that probably sounds really complicated, but like you can just put 2 words for all of that: projectile motion. So you have to have a specific angle, a specific velocity, and a specific direction. Now I missed that one. So obviously there's something off about my velocity, my angle, or my direction. So if we do our calculations right, I wouldn't have missed it.
So in order to help Harmon shoot it in the basket at the right place, we can take the X displacement, or how far she is from the basket, and the vertical displacement from the hoop directly straight down. We can calculate using the velocity and the angle she shot exactly where the ball is going to go.
Did you guys have fun today?
Yeah!
Who can tell me something they learned?
Speed.
And what speed?
How fast you go.
Good job.
Thank you. How fast?
Okay, who else?
Gravity.
Gravity.
And what's gravity?
Earth's surface.
Close. It's Earth.
Body.
Earth is
Pulling on us.
pulling on
Good
us.
job. How about you?
Distance.
Distance. Good job. And what's distance?
It is like how far you go.
Good job.
Yep, it's all the steps it took you to go from one starting place to the finish.
How about you?
Position.
Position. Good job. And what's position?
Where you're standing or where at.
Good job.
Good job.
You guys have more? Okay, let's do one more round.
Acceleration.
Acceleration.
And what's acceleration?
I was thinking of that. We don't
What
know.
happens when, remember when she was being chased by a bee?
Yeah.
And she had to start, what?
Running.
Running what?
Speed.
Faster, right? So her velocity, or how fast she was going in the direction that she was going, had to get faster so she can get away from the bee. That's what acceleration is. Viewers at home, write down something that you learned today on the space provided.
So we're gonna apply.
So
force
if you
on
can
him.
see, as she's pulling him, does it look like he's getting faster?
No.
Oh.
Okay. So for the viewers at home, I already messed up.
Next, we're gonna talk about distance. Go. Velocity, acceleration, and I forgot. Let's start again.